Today we are going to study about operations on sets. So just like the way we have operations for numbers like division, addition, subtraction, multiplication, we also have operations for sets. So to begin with, let us take a set A which has got elements 1, 2, 3 and 4, and set B which has got elements say 4, 5, 6 and 7. So since we are trying to find out the union and intersection of these two sets, union is denoted by U and intersection by inverted U. So when we write A union B, we write A union B as A U B and A intersection B as A inverted U and B. So here we are trying to learn about union and intersection of sets. So say A is 1, 2, 3, 4, B has got elements 4, 5, 6, 7. What will be A union B? So A union B will be set of all elements which are in A or B. So which are in A as well as in set B. So here A union B, let me write again, A union B will be equal to 1, 2, 3, 4, 5, 6, 7. So all elements of A as well as all elements of B. So you can also say that A union B is the totality of the elements in both the sets, is the totality of the elements in both the sets A and B. So if you want to write it in set builder form, so we can also write A union B is equal to X is such that X belongs to A. So all elements which belong to A, we can see all elements of A are in A union B, or X belongs to B. So all elements of B are also in A union B. So A union B can also be written as X is such that X belongs to A or X belongs to B. So this union, please read union as or or you can also say both. So elements which are in both A and B. So say talking about intersection of sets A and B, intersection of A and B. So now A intersection B. So A is 1, 2, 3, 4. I'll write A again for you. A is 1, 2, 3, 4 and set B is 4, 5, 6 and 7. What will be A intersection B? So A intersection B, intersection or elements which are in common in both A and B or overlap. So what is common between A and B? So A intersection B, we can clearly see that A intersection B 4 is common in both the sets A and B. So A intersection B here will be only 4. So 4 is the only element which is common in both A and B, or it overlaps in the sets A and. Let us take one more example. So this time I am writing set A in set builder form. So set A is X is such that X is a prime factor of 240. So set of prime factors of 240, and set B is equal to X is such that X is the sum of any two prime factors of 240. So set A has all the prime factors of 240, and set B is the sum of any of these two prime factors of 240. So to begin with, obviously we'll have to find out the prime factors of 240. So 240, we can write 240 as 24 into 10. 24 is 2 into 2 into 2 into 3, and 10 we can write as 2 into 5. So 2 raised to 4 into 3 raised to 1 and 5 raised to 1. So these are our 2, 3 and 5 are our prime factors. So we have found our set A. So set A is 2, 3, 5. So the 2, 3, 5 are the prime factors of 240. Let us try to find out set B. Set B is sum of any two prime factors of 240, sum of any two prime factors of 240. So let us begin with adding 2, 3 first. 2 plus 3, 5. 2 plus 5, 7. And then 3 plus 5, 8. So these are the options available with us. So set B is 5, 7 and 8. 5, 7 and 8. Let me use the same font, same color. 5, 7 and 8. So again we'll try to find out A union B and A intersection B for the sets A and B. So A union B is, which we know by definition that A union B is such that X belongs to A or X belongs to B. So so either in A or in B. So A union B is the collection of elements present in both A and B. So it will be 2, 3, 5, 2, 3, 5, 7 and 8. So this is A union B. A union B. Talking about A intersection B. A intersection B. By definition, A intersection B, this represents AND. Intersection represents AND. Union represents OR. So X is such that X belongs to A and X belongs to B. So belongs to both A and B. So which means overlap or common. So what is common between A and B? 2, 3, 5 and 5, 7, 8. So we can clearly see that this 5 is common in both A and B. So our answer is A intersection B is only 5. So this will be A intersection B. This was A union B. Now we can also represent this information through pictorial representations, also known as Venn diagrams. VENN, Venn diagrams. So Venn diagrams are most times they are easy to understand. So math being a very abstract subject, so these pictorial representations sometimes help us to understand it easier. So since we are talking about A and B, let us take the same A and B from the previous question. So our A was 2, 3, 5 and B is 5, 7 and 8. So if I would try to represent this through Venn diagram, so first of all we'll make a universal set. We'll make a rectangular box. Let me redraw this. So we'll make a rectangular box and I'll write U here. So U here means universal set. So you must be wondering, what is this universal set? So since we are talking about, say, natural numbers here, so universal set will be the set of all natural numbers. So suppose if you are talking about, say, colors, so universal set will be The set of all colors. If you're talking about countries, COUNTR. Yes, so universal set will be the set of all countries. So depending on the question, depending upon the situation, universal set will keep on changing. So here we are talking about say natural numbers 2, 3, 5, 5, 7, and 8. So universal set is the set of all natural numbers. So obviously this set will contain A. So I'll make A. So make a circle which represents A. A has 2, 3, 5. So I'll write 2, 3, 5. And then we have set B. Set B will also be contained in the universal set 5, 7, and 8. So since 5 is common, set B is 5, 7, and 8. So can we identify or can we figure out what will be A union B and what will be A intersection B from this Venn diagram? So we know intersection is the area of overlap. So this is the area of overlap. Clearly we can see that 5. 5 is the area of intersection, the common element. What will be A union B? A union B, we know elements which are in A or in B, or we can define it as the totality of the elements in both A and B. So A union B will be 2, 3, 5, 7, and 8. And while representing in Venn diagram, we'll shade the complete region comprising A and B. So this is how we represent union and intersection of sets through Venn diagram. Let us take one more example. AB, let's set AB 3, 4, and 5, and set B is say elements 6 and 7. It consists of elements 6 and 7. So A union B, what will be A union B? So we know A union B is the set which consists of elements from A or from B. So it is basically a collection of the elements which are there in both A and B. So we'll write it as 3, 4, 5, 6, and 7. So A union B is 3, 4, 5, 6, and 7. And what will be A intersection B here? So elements which are present in both A and B or are common in both the sets A and B. So if we observe carefully, we find that there is no such element which is present in both A and B. So A intersection B here will be represented by empty set or null set. So please note that when A intersection B is empty set, such sets are known as disjoint sets. So A and B are disjoint sets. Let us take discuss one more important concept, which is complement of a set. Complement complement of a set. So let us assume that we have a universal set which has got elements 1, 2, 3, 4, and say up to 9. 4, 5, 6, 7, 8, 9. And then you have set A which has got elements 1, 2, 4, and 7. Okay, let me rewrite this completely for you. So we have got 4 to avoid any confusion, 5, 6, 7, 8, and 9. And A is 1, 2, 4, and 7. So what will be complement of a set? So complement of a set is generally defined or written as A complement or A complement, or sometimes also written as A complement. So there are various ways of representing writing A complement. But A complement is defined as, I'll use A dash. A complement is defined as X is such that X does not belong to A. So A complement, the elements of A complement should not belong to A, but but they must belong to universal set. So elements should not belong to A but belong to the universal set. So what are the elements here in our example that do not belong to A but belong to universal set? 1, let us begin with 1. 1 belongs to A, so 1 cannot be an element of A complement. 2, 2 also belongs to A, so it cannot be element of A complement. 4, 4 belongs to A, so we cannot choose 4. 7, 7 also belongs to A, so we cannot choose 7. So what will be A complement? A complement will be 3, 5, 6, 8 and 9. 3, 5, 6, 8 and 9. So A complement is the set of elements which belong to universal set but they do not belong to set A. So this is A complement. Let us take one more example to understand complement better. Say this time my universal set, I'll take a different universal set. My universal set now consists say, of colors red, yellow, blue, orange and green. And my set A consists of colors yellow, blue and green. So what will be A complement? So we know A complement is a set of elements which do not belong to A but belong to U, which do not belong to A. So we have to eliminate yellow, blue as well as green. So what are the options left? Red and orange. So A complement is red and orange. Okay, this is it. This is our answer. I hope you would have understood the concept of union, intersection and complement of a set. Thank you and have a good day.